All right, this is a warp drive test model 2. Uh, the problem with the first model was the injection chamber was 3 inches, but the actual glass inside the injection chamber was like 1.5 inches, and the magnetron wouldn't fire through the small glass. It would actually be absorbed, so the microwaves would never make it down to the main chamber, where this is where the action is supposed to happen. So I had to spend a lot more money. Each one of these pieces is about $100, so this would be $300. One, two, three. I went with this because one of these pipes in copper alone was around $300. So instead, I decided to go with a stainless steel chamber. It doesn't seem to make a difference because it's actual conduction of the metal, which stops the microwaves or keeps the microwaves bouncing around. Okay, so the main reason why I used copper up here for the injection chamber and why it was so key for me is because I can solder to it quite easily. So like right here, there's a seal, and I can seal the pipes in too with solder. Um, and the main reason why I want to connect the gauge in here, like this isn't really connected yet, but it will be pretty soon. This is just how it is. I already threaded everything in place, so everything is bolted together the way it's supposed to be. But as for the injection chamber itself, yeah, it's pretty well done. So this is the injection chamber, and what this is it was a magnifying glass. Let's see if we can, there you go. It was a magnifying glass from one of my kids, and I ended up taking the lens out and cutting it down because the glass is so thick it won't break so easy. So I don't know, the glass is like 4 millimeters thick. It's like that thick, uh, which is like a quarter of an inch thick. And because of that, it won't break so easy, and it was easy to grind down without breaking or cracking. And then after I ground it down, I ground this fitting right here fits inside this flange quite well, so it provides a seat for the glass. And so I put ground the glass down to sit on the seat, and then I used super glue and glued it in place to give it a perfect seal. And when the vacuum pulls on it, it's going to force the glass down onto the seat. All right, so that makes that finishes the injection lens. And I've already tested it out on the 3-inch cylinder. The microwaves will travel all the way through the cylinder, so a 3-inch glass would be fine for shooting microwaves through. And apparently, white light works the same way with microwaves, so it passes through glass quite well. It's just not affected like light is inside the lens. This chamber just provides a bolting mounting area. So that's the main point of this chamber right here. It's a step down cylinder. It made this not so expensive because this could have been even more money. So they made it less expensive by getting the step down cylinder. And that gives me the mounting bracket, I guess you could say, for the tools that I need to connect to the vacuum chamber. All right, so this is the main part of the vacuum chamber. It's just a vacuum chamber. Because it's a V flange, it has a quick connect. It has quick connect fittings. So all I need to do is put like an aluminum tape or a copper tape around here, and then put the clamps on, and then it'll give me a seal and a seal from the microwaves too, so they can't come out. So that's that. All I got to do now is, well, solder the things, the piping together, and then it's ready to go. So this I know will work. So this is going to be the test model that is actual test model that will work.